let's consider the following problem. Let's say that we want to compute the area of some type of shape. So one thing we could do is write a method, like a static method, called, let's say, I don't know, double area. Okay? And then maybe, let's say we want to specify the kind of shape. Okay? So, yeah, so like for example, we could do a case analysis and say like, if S is, let's say, circle, then, okay, so we actually run into a problem here, right? The problem is that different shapes have different ways of computing an area, okay? So for a circle, obviously you would need to pass some information like the radius of the circle, right? And for a rectangle, you'd have to pass in two values, the length and the width. For a triangle, you'd have to pass in three values, which are the lengths of the three sides. So, one way we could do that, in theory, is just receive like an array of values and just assume that the user has complied correctly. But obviously, we don't assume the user can do anything correctly, so what we can do is take advantage of interfaces. Okay? That's what we've been talking about. So, an interface, in this sense, would have the following behavior, right? We could have, let's say, an interface called IShape that has the following methods. So, we will have one for computing the area of a shape, and then another, let's say we also want to compute the perimeter. Okay? So, remember that we've said that interfaces define behaviors for an object. Okay? They define behaviors for an object. So, what we can then say is that we can have, let's say, a class circle, implements IShape, and then now it of course has to override the public double area, and then it'll compute that somehow, and then it has to do the same thing for perimeter. Okay? But the question from there is, well, how do we know how to compute the area? Well, there's no parameters. We don't give anything to either of these, but we don't need to, right? We can get that information via instance variables. So we can have like a private double radius, and then just instantiate that, or define it, not instantiate it, in the constructor, like this dot radius equals radius. Okay, and obviously this just looks like chicken scratch, but let's actually go to the IDE and work on this. So we're first going to create an interface, and to do that we just right click, new class, and then click interface, and we're going to type in the interface that we want to use, or that we want to define. Okay, and now we're going to define the two methods. We're going to say double area, double perimeter. Okay, now if you were writing this on your own, I would expect you to write in some Java docs here. It says like, it just says what the method is supposed to do and how subclasses or subtypes of this interface are supposed to override it. Okay, so let's create the circle class. Okay, we're going to say that it implements IShape. Okay, now of course we're going to get this red line here because we have to implement the area and perimeter methods. So we'll just automatically do that, and if you're curious how I did that, I'll do it again. Hover over it, don't click, hover over it, hit implement methods, or you can press, if you're on Windows, Alt Shift Enter, implement methods. All of these should be generated, and you should also click generate missed Java doc, and then this will allow you to very quickly define how to, or this will very quickly add the Java documentation comments, which of course you need if you are writing these methods for your problem sets or your labs. Okay, but for now we're just going to get rid of them. So now the question is, how are we going to actually test this thing? Well, we first need to define what a circle is. Okay, So let's say that a circle has a radius, and the constructor should then, of course, receive one and assign it to the instance variable. Okay? And then for the sake of it, we will just write the getters and setters. So we're just the getter and the setter. Void set radius, double r, this dot radius equals r. Okay? So this is a mutable circle that we can pass a radius, get the area, and get the perimeter. Okay? Now how are we going to test this? Well, we can test this by going to, we'll first just create the necessary file for it. Everything should be imported correctly. We'll change these to be test area and test perimeter, just to be consistent with how we name things. There we go. Now, how are we going to test this? Well, we need to actually create this as an instance of IShape. Now, you don't have to do it that way. You could do something like, so let's just first, or let's actually do the at before each way of doing this. So I'm pretty sure I've talked about this in a previous video, but the idea is that if we're going to be testing a bunch of IShapes, like this, and then maybe we have another one, maybe we have another, doesn't matter. If we have a whole bunch of these, then we're going to have to redefine them down here to test a separate method, and we don't want to have to do that. So what we can do is just define a method. We can call it, let's say, setup or init, it doesn't matter. And then we can just make these instance variables. So private final IShape, oh sorry, they can't be final. Private IShape C1, private IShape C2, private IShape C3. And then inside of here, we'll just define these to be this dot C1 equals new circle, this dot C2 equals new circle, this dot C3 equals new circle. There we go. So inside of here, so remember what this does. This will, before each of these methods, it will instantiate C1, C2, and C3 to be new instances of circle with these specific radii. Okay? And this is important because these circles are mutable, and we can change their properties, which we're going to do inside of these methods. So if we change them, we don't want to have to reset them ourselves in a different method, because if we change it and we don't have this before each, then the changes will persist from one method to another. Okay? So let's now test the methods. Let's do, so what is the area of C1? So the area of a circle, if you don't know, is just pi r squared. And I don't know that off the top of my head, but what I can do is just actually type that in here as the expected result. Okay? Although this is not the greatest thing in the world, you should actually, like, maybe verify with a reputable source of what the formula is, but that's perfectly fine to do in this case. So we'll do this dot C1 dot area. Okay? And then we'll do the same thing for C2 and C3. So this will be 100 and 100. Very good. And we can also do, like, let's say this dot C3 dot, let's change the area. Actually, wait, okay. So this is a good point that I sort of forgot to mention. So the reason why we want to instantiate these as IShapes and not circles is because we want these to be as general as possible. If we instantiate them as circles, then the problem is that we can't pass these to anything that can work with just a general IShape. And the idea is that if circles are IShapes, if they behave like IShapes, then they should work with anything that supports an IShape. And what that means is that we can actually, the sort of issue with that is that if you define a method that's not in the interface, you can't call it on that. So we actually can't call get and set radius on these objects without doing something first. What we can do is say circle, we'll say CC3 equals, we can do a cast to the circle itself, okay? And there's sort of an issue here where if this were not an instance of a circle, if C3 were not an instance of a circle, then this would throw a class cast exception, okay? But now that we do, we can change the radius. Let's make it 10,000. And then we can say, this will be 10,000, okay? And notice that we're not going to use CC3. We're still going to use this .c3. And the reason why is because CC3 is just a casted alias for C3, okay? It's not like it's a new object. So these things still point to the same thing in memory, okay? So now let's actually implement the area method, okay? So that, of course, would just be the radius times math.py. Okay? Very good. So let's run this, and we'll see what happens. Okay, so we get what I expected. We get a precision error. So if you're ever working with pi, remember pi is irrational, although it is an approximation of pi. So what we'll need to do is have a delta. So we'll just say if it's within 1/10,000th of the actual answer, then that will be a good enough approximation. Okay? So now if we run it, everything works as expected. In the next video, we'll do the other classes, and we'll also do the perimeter.